Hello folks, today we're looking at solid edge assembly features. Alright, these are features that reside in the assembly level that allow you to put cutouts, sweeps, lofts, and do some weld functionality. As you notice here, I'm in the features in the assembly right now, and we have some grayed out features. I'm going to show weld here in a moment, but we're going to concentrate on now is we have an assembly here. Alright, I have two separate assemblies. I have an assembly, let me turn on the tube so you can actually see. I have a tube and some kind of attachment that allows you to attach the tubes together. And of course we have two tubes that you can weld together. So we have two different ways to join these. Alright, so the first one we're going to look at is placing a hole in here and putting some rivets in here to hold this together. Alright, so again we can go ahead and create an assembly feature. That is actually the first one in the list, as you'll notice when I go ahead and fire off whichever feature I want. So we can do this either with a cut or a hole. Alright, I know I'm putting a 3/8 rivet in here, so I'll need a hole for clearance. Alright, so I'm just going to actually use a hole command because this actually has more intelligence than just a cutout. And as I mentioned a second ago, we're going to create an assembly feature. Alright, assembly feature is a feature that resides only in the assembly level. Alright, so this is like a post feature creation. So after I have my parts cut, have this little bracket machined, and when once we put them together in the assembly, maybe they go into a jig and they both get drilled at the same time, so the holes line up perfectly. Sometimes that's kind of hard to do if you make the parts individual and create the features. Alright, so again, we'll go ahead and select that. Go into my cutouts here. Alright, I want to go ahead and line this up. Let's go ahead and turn the shading off so you can actually see what's going on the inside here. Alright, so there is my frame piece, and there's the little extrusion that goes in the middle. So I'm going to go ahead and use this to line it up with. And we'll go ahead and place one on each side. And we'll place the dimension between the two. Alright, so they're going to be the same. So after I create them, I'll go ahead and actually put a formula between the two. Let's go ahead and make this 0.625. That should work. And again, I want these to be the same all the time, so it's a quick mouse click by saying edit formula and selecting the dimension that you want it to match. And of course I did it backwards. I should have actually chosen the other one first, but here we go. So these will go ahead and move at the same time, and they'll stay centered on the geometry. So let's go ahead and punch these through. Alright, so we want to just say through all, and go ahead and give it the direction, and we'll say we're going to cut all the way through all these three parts. Alright, at this moment, maybe at some situations you would want one part cut and not all three parts cut. Well, simple enough. You can come over here, because right now everything it's looking at getting touched is going to have a cutout in it. So I'm going to go deselect it. Well, maybe I just want this to have a hole in it and maybe one of the tube extrusions. You know, then this one will actually have a hole left off, and there'll be a hole on the inside of this one. But in this situation, let's go ahead and punch holes in all three parts. And there we go. You can see through the part now. Let's make it a little clearer. I'm going to go ahead and do a section through this guy so we can see on the inside a little easier. I'm not going to dynamically do that. Let's go ahead and do that with just a portion of the hole shown. Actually, let's do that again. Sorry. There we go. There we go. Alright, so you can see the extrusion and the actual two frame members. And we have a particular thickness. Alright, so I want the pardon me, I want the rivet to fit perfectly in there. So I'm going to go ahead and grab my rivet part. And what I did on this part down here is I created a adjustable part as it would be. Alright, so this is 1 inch from the bottom of the head to the bottom of where the rivet gets cinched together. So what I'm going to do is actually use this, and as I place it in here, you'll notice what happens. We get this little option to say place as adjustable or place as rigid. If I place it as rigid, it's going to place it just as I designed it. If I place it as adjustable, then it gives me an option to come in here, and you notice it's fairly tall. So I'm going to go ahead and say, you know what, I need a distance. So what I'm going to do is actually say, well, I need a distance from this top hole to the bottom hole, and that's going to give me a value. Oops. Let me do that one more time. Make sure I get the right feature. I want, there we go, that top face down to that hole right here. There we go. So now I have my 0.225 value, and say okay. As soon as I do that, you notice that my rivet automatically adjusts to compensate for the material thickness. Alright, so the last step is to go ahead and just put some relationships on it. And on round parts that go in holes, single edge selection is all you need in solid edge. So as I place it, you notice the part comes in here and it's fully constrained. It has a mate and an axial locked, so it's not going to rotate in the hole. And I can go ahead and turn off the section view so you can actually see where it gets placed. And I can take my time to go ahead and place it in the other holes. But in this one, I'm just going to go ahead and skip over to the weld environment. Alright, so the first one we placed was just an assembly feature. The second one, let's go ahead and create this. Excuse me. So if I go to features and we're going to toggle this. So the reason I can place weldments on here is because this is toggled as a weldment. So I can come over here and apply a bead density. So once it's placed in a top level assembly, or just if I inspect the properties of this guy, it'll give me the weight of the two parts and the actual weight of the weld. Alright, so I'm going to go ahead and leave that as the default here. Now under features, we have some ability to create some rounds and chamfers. But what first thing I'm going to do is, most people know when they weld tubes, there's usually a weld gap between the two tubes. So that's the first thing I'm going to accommodate for. So I'm going to come over here and find the actual property that dictates the spacing between the two. And it's the last one right here. So I'm going to say 0.125. There we go. So we have an 1/8 inch gap in here. And these are fairly thin wall parts. So I'm going to go ahead and give it a chamfer so we can get some full penetration on here. And I'm not going to do the full chamfer. This, I think the part's 0.1. I'm going to go ahead and do this as 0.0625. Alright, so in this situation, we're going to go ahead to go down to the second option, which is to create an assembly-driven part feature. Alright, simple enough. Toggle that. Pick my edges that I want to apply a chamfer to. We'll go ahead and we'll make it roughly half the thickness of the part. Oops, let me go ahead and do that and put one on this edge as well. There we go. So as again, I created this as an assembly driven part feature. Alright, so let me go ahead and save my assembly. Once it's saved, I'm going to open up the part and show what we accomplished here. So I open this up. Alright, and there we have our chamfer feature. And you notice it has a chain link. Basically what it's doing is it's linking itself back to the assembly level. So any given time I open up this tube by itself, so if I said file open part, the first thing it would tell me is, hey, this part is part of a top level assembly with assembly features. Would you go ahead and want to open the top level assembly instead? I would say yeah, then it would open up the assembly for me and find all the parts. Alright, so let's go back now that we have our chamfer and do what we intended to do a while ago, which was create a weld bead between the two features. Alright, there's multitudes of ways of creating weld features in Solid Edge. We can actually just label a weld if we wanted to and just call it out what we have. I can say this is just a groove weld and give it some values and call it a day. Maybe somebody wants to actually draw that in there. Alright, so we have a command for groove weld, and we can also do other types of welds that we don't really have commands for. Of course, a fillet weld is just a 45-degree fillet that'll wrap around the profile, but it won't really work in this situation because we have such a large gap between the two faces. Alright, so only really solution for this one is going to be a groove weld. Alright, the first thing I'm going to do is let me bump up my resolution. You notice the edges are kind of tessellated, so it gives you kind of an octagonal shape. I'm going to adjust my sharpness level here by a couple. Now that smoothed it out considerably. Let it catch up. There we go. Alright, so now let's do a groove weld. So again, under features, let's do the groove selection here. Alright, so the first thing we need to do is pick a face to start from. Alright, so I'm going to say I want to actually have a weld bead that goes from this face and this face to the other two faces. So let's go ahead and select these two faces and accept it. Before I move on, I want to go ahead and do an extra step here. This allows me to dictate the top and the bottom of the path. Alright, so this is going to be the top of where the weld bead is associated with. Go ahead and accept that. I'm going to get the second bottom edge, so there's the bottom edge, and accept that. Alright, now we move on to the target face. Let me rotate around so I can actually select the other two faces. There we go. So we want that face and that face as the two faces that we want. And go ahead and accept that. And then again the same steps. We're going to go ahead and accept the top path. There we go. And then we'll accept the bottom path. And hopefully, if I got all the edges correct, when I right click and preview, I'll get a weld bead between the two faces. And I did. Alright, so again, let me turn off some of the sharpness. I got the little set too high. It's starting to slow down a little bit. Alright, so again, let me do my cross-section view. Let me get rid of this keep Windows 7 basic color. Sorry about that. Alright, here we go. My graphics card's giving me a little issue here. So I'm going to go ahead and then create that little dynamic section. And that'll work. Alright, here we go. And of course, there's the weld bead, and of course there's the actual two tubes. Again, we have an assembly driven feature, which is the actual weld bead. Expand that out. So there's the assembly feature, and of course the two assembly driven part features. So they can be used in conjunction. So the chamfer is in the part level, but the actual weld bead is in the assembly. And any given time that I come and adjust the spread distance on here, so I have that set at 1/8. You know, this is kind of more than you would ever do with a 1/4 inch, but just to show that the weld automatically adapts and moves with it. There we have it. Okay, so let me go ahead and turn that off. Alright, so we did an assembly driven feature, and we did an assembly driven part feature. And the next thing we're going to do is create a feature. Again, on this situation doesn't really matter. I'm going to go ahead and say maybe they need an access hole that gets welded up later. Alright, so let's go ahead and just pop a hole in the assembly. This time I'm just doing a regular O cutout, so I'm just going to go pop a little circle on the profile here. And maybe go a little bit down into it, and let's build that little hole. Alright, so maybe we have our hole in there, and some stuff gets put in there and welded, etc. Then the last step is it gets filled up. Alright, so we're going to do a little plug weld. Alright, so let's go ahead and just do an assembly feature now. So let's do an extrude. And I'm just going to include the geometry that I have there. I'm going to go ahead and just select that edge of that weld that I created. And let's give it a depth here. Let's just go down to the bottom edge of that inside hole. Oh, I went the wrong direction. My mistake. Again, assembly feature, easily to edit the definition of. And change the extent step, so we don't want to go that way, we want to actually go down into the part. There we go. I did that correct that time. Alright, so let me turn the pipe off, or the tube, and there is the little feature, a little purple feature right here. Alright, so what we're going to do is turn that into a weld. So with a label weld, pardon me, and we're just going to come over here and say, you know what, let's go ahead and just call this, you know, melt through, or spot weld, or what have you. You know, seam welds, we have all a multitude of different styles. Let's just say spot weld. Let's say we don't want it convex, we want it ground flush. So we'll grind that flush, we'll say okay. All I gotta do is pick the edge of this guy and right click and accept. And as soon as I do that, you notice it changes from that purple to a weld color. And now, if I do a call out on this guy, so if I go to PMI and say, you know what, tell me what that weld's going to look like when I get to the assembly. And I want to say okay, but I want to actually pull it from the actual, tie it to the geometry as opposed to filling it in. As soon as I do that, you notice it's a spot weld with a grind finish on it. Alright, so that is an assembly feature. That's an intelligent weld now. So I just turned a simple protrusion into that cutout. So anytime I do change that cutout, that protrusion will fill in with it and automatically adapt and move with my tubes. Alright, turn those back on. Alright, so the last thing we're going to do is create a feature. We're going to use the Lash option. We're going to create an assembly feature that's pushed down and controlled via the part level. This is new to, I believe, ST6 and 7. This came out. So what I want to do is go ahead and copy one of these tubes. So let's go ahead and copy it. And let's go ahead and let's say I need to put a tube that kind of runs down the edge of this guy. So let's rotate this tube around. This is the copy one. Alright, let's say a 120. That looks good. Alright, so let's go ahead and adjust the location of this guy here. Let's move it in a little bit. And tell you what, let's move it down. There we go. So now I'm going to go ahead and cut this to adopt the side of this, to make this tube fit this guy. But if you notice in my Pathfinder, I got tube 2 and tube 2. So if I cut this tube, well, of course, this tube's going to have a cutout on the edge of it too. Well, I don't necessarily want this in this situation, so we have something under replace part. All right, I'm going to replace this part with a copy. All right, so I'm going to go ahead and say, you know what, let's go ahead and replace this part with a copy, the exact copy of it. Let's call this tube 3. There we go. Overwrite that one. That's right in there. Yep. All right, so now I have tube 1, tube 2, and tube 3. All right, so I have 3 separate tubes. Now I'm going to go ahead and do the last feature. And it's going to be a cutout. Create an assembly feature. And these are sync parts. I created them in synchronous. So, you know what? I want my cutouts to try to be a sync as well. And I'm going to go ahead and use the edge of this part. So I'll just select that. Notice we got a little chain link there that says, hey, these two parts have the geometry that's going to tie together. And let's cut this in both directions. So I want to cut, there we go. And again, I don't want to cut both parts. There's no reason to have that selected, so I'm going to deselect that and reselect this guy so it adopts the 45 or whatever 20-degree angle I have there. So now you see, if I turn off tube 3, we get a nice little section cut there. Turn that back on. So any given time, you know, if I want to come back and say, hey, let's put a fillet weld on there, so I can come back and let's do a chamfer. Let's do this as an assembly level. So again, we can mix and match. 0.063 is good. And let's just throw a couple weld beads on here. We'll just do a fillet weld. And let's see, base thickness point. Same as the chamfer here. So I'll just go ahead and say, let's put a weld bead on this face and that face right there. There we go. I could actually make that weld bead a little thicker, but I could go ahead and just create that weld bead all around if I wanted to, or just on the faces that I select. So here we go. So that again is the 3 different types of features that we have in our assembly. Again, our cuts, the sweeps and lofts works the same way, where you can actually sweep a protrusion or sweep a weld bead through a feature. And the last thing we can do is assembly post-treatment feature is create some PMI geometry. All right, PMI geometry is product manufacturing information, and that was the weld bead that I actually created here. And of course, we can also create all our assembly dimensions. So if I wanted to retrieve my dimensions from the assembly, I could take my time and go through, and place. Sorry about that. Let me do that again. Actually, let me use a different style dimension. There we go. That's what I was looking for. So this is what I was looking for, and to place, I could place angles and whatever dimensions I want. I can come over here and say, you know, what angle is that? 120 degrees. I already called the weld symbol out. So once again, I get to the assembly, take that into draft, and start retrieving this information. So I don't have to worry about actually creating it in the draft. I can do it right here in the assembly. We can also save this out as a package collaboration file, so you can send that through a viewer, and people can redline it, take a look at it, do multiple things with that PCF file. Alright, so that pretty much wraps up our assembly features and our weld features that we can do as post-treatments in Solid Edge. Again, thank you for watching, and if y'all have any questions, feel free to contact us at Swoosh Technologies. Again, thanks.